Suppose a cubic function is being sketched. It has a maxima point and a local minima point. Now, how do we find the coordinates of the maxima and the minima using calculus? We use derivatives. Now, the function f of x is x cubed minus 6x squared plus 9x plus 2. And now let's explain the derivative of this f prime of x. Well, the derivative is simply defined as to be the slope of the function at any given point x. So if we had an x point, at this point our gradient would look something like this. At this point our gradient would look something like this. At this point our gradient would look something like this. Well, what is the gradient in the maxima? Well, the gradient in the maxima is simply going to be a straight line, and so we call it zero gradient. Likewise, in the minima, the gradient is also a straight line, and hence a zero gradient. So to find the x-coordinates of these maxima and minima, we simply equate f prime of x to 0. Using the power rule, we get an expression for f prime of x, which is 3x squared minus 6 times 2x plus 9 plus 0. Simplifying this gives us 3x squared minus 12x plus 9. Now, since this is a quadratic and has two solutions, we're going to be using the quadratic formula. And a, b, c are just quadratic constants. Now, the first solution is minus 12 plus square root 144 minus 4 times 3 times 9 over 2 times 3. And we do plus minus since there are two solutions. Now plug this into your calculator, you're going to get the first solution as 3 and the second solution you're going to get as 1. Now if we look, since the x-coordinate of the maxima is less than the x-coordinate of the minima, we take the second solution as to be the maxima and the first solution to be the minima. Now plug the x-coordinates into the original function and you're going to get y-coordinate of the maxima and y-coordinate of the minima. And so 1, 6 and 3, 2 are going to be the coordinates of the maxima and minima respectively.